Hey guys, we're going to sneak some geometry in today. And again, I want to remind you, just in case anybody asks you, oh, you're doing Saxon math, why aren't you doing geometry? And the answer is yes, we are doing geometry. Saxon math includes geometry. America's like the only country in the world, that has gasoline engines and air conditioning that still does geometry as a separate course. It's insane. They've known for 100 and something years that kids do worse if they take geometry as a separate year. By the way, Saxon now, since John Saxon died decades ago, they've changed it so the new Saxon stuff has geometry. Don't be fooled. Don't take Saxon geometry. Keep taking the additions, using the additions with geometry mashed in there with everything like we're doing now. So, all right. Let's talk about segments. A line, remember, if we've done this before, a line looks like this. It looks, just goes infinitely in both directions. A segment looks something like this. Let's say, I don't know, this is QG, okay? And you could say, oh, this is line QG, which means it goes through those 2 points. A line is defined by 2 points. If you have 2 points anywhere in space, there's only one line that's going to go through those 2 points. Okay, you could name this line QG, or you can name it line GQ, or whatever. It's fine. The segment, and sometimes they'll go like this. They'll go, okay, that's supposed to be a G anyway. That's line GQ. They might say something like that. If they just go like this segment GQ, like that with no arrows, that means we're only talking from here to here. Okay? They could also name it segment QG or anything like that. If you want more examples on your Booker's page 364, there's a few of those. Okay, so let's look at this. It's just simple mathematics as far as this goes today. In this figure, the length of segment LM, in other words here, is 4, and the length of segment LN is 9. What's the length of segment MN? Well, obviously it's going to be 9 minus 4 or 5. That's just getting your brain to think geometrically and do the arithmetic. Okay, you should make sure you write this down. This is a definition that you need to make sure you know. By the way, in the back of your book, if you look, there is something called a glossary. A glossary is simply a dictionary that's specific to the book that it's in. And if you go back to your book, in your book on page like 693, isn't that depressing? There's 600 pages in this book. Go to page 693, and that's the beginning of your glossary. So you can look up words if you forget what they mean in that book. And also in your book is called an index, and that is a kind of a reference page. So if you look up this word complementary, if you forgot what it was, you could look up, in your index. Let's see, the word complementary, and then you go, oh, it's on page 728, and that's another way for you to look up that word. But two complementary angles are right next to each other, and they add up to 90 degrees. And this is what it looks like. Complementary angles. A complementary angle will be something like, remember we named these angles like PQR, or we could also say RQP. And this angle here, the first one we did was just then, could be angle, excuse me, SQR or RQS or whatever. Now in this one, you couldn't say, oh, look at there. You wouldn't want to tell somebody, hey, there's angle Q. The person will look at you and go, what do you mean angle Q? Do you mean this angle? Or do you mean this angle? Or do you mean the entire thing? Or whatever? That angle would be PQS or SQP. So you need to be specific about that. Complementary angles add up to 90 degrees. Don't forget, that's called a right angle. Okay? Supplementary, they add up to 180 degrees, which is a right angle and another right angle. So the whole thing looks like a straight line. In fact, sometimes they're called straight angles, supplementary angles. So you can go alphabetical C, complementary, comes before S, supplementary. So 90 comes before 180. That's one way to remember it. Okay? There are two examples of supplementary angles. These guys add up to 180. That doesn't mean each one of them is 90. It can be a 179 degree angle and a 1 degree angle. That'd be like a real pain to try to draw those two. So anyway, it could be, this one here and added to this one here. These two, in other words, are supplementary angles. That's it. All right. So this figure here, angle RWT is a right angle. In other words, RWT is a right angle. In other words, this is 90 degrees if you were to draw it like that. Which angle is the supplement of angle RWS? Well, let's look at that. RWS is this angle, right? So what's the supplement of that angle? In other words, which one adds up to 180 degrees if you add it? Well, it's angle RWQ, or if you want to call it QWR, that's okay. And which angle is the complement of angle RWS? Well, this is the 90-degree angle from here to there. The complement of angle RWS would be this one here, SWT or TWS, because both of those together add up to give you a 90-degree angle. Okay. All right. Let's look at the practice problems on page 366 and pause it and try it. Okay. A is going to be 34. Pause it and try B. Complement will be 30 degrees. 30 plus 60 is 90. All right. Pause it and try C. Supplement will be 120 degrees because 120 plus 60 is 180. Make sure you get those down. All right, pause and try D. Acute angles, remember, are less than 90. So if you have two angles that are less than 90 degrees each, they can't possibly add up to 180 degrees. All right, pause it and try E. 1 and 2. They're supplementary. Okay, last one, F, pause it and try that. Okay, 2 and 3 look like they're about 90 degrees, and they are. We'll talk more about why later on. Okay, have a great time with your stuff today. Take a deep breath, go get a drink of water, come back and knock that problem set out and the warm-ups out of there. Then, man, you got the rest of the day to do other stuff. So, see ya.